Okay, here we go. We've got our next Math is Everywhere topic of the day, and now we're going to start Unit 6. The first thing we're going to talk about via video here for Unit 6 is this concept: solving addition and subtraction equations. We're going to talk about what it means to solve an equation, and we're going to solve equations using addition and subtraction. So let's start off with an example. Let's say I had a certain amount of money, but I'm not going to tell you how much. We're just going to call it X because it could be a variety of different numbers. And because it could be a variety of different numbers, we're going to call it a variable because it could vary, or it could be a variety of different numbers. And so we're going to use the variable X for how much money I have. Well, then let's say I take the amount of money that I have and I add $1 to that. Well, then if I told you that after adding $1, the amount of money that I have equals 8, you should be able to go back and figure out how much money I had in the first place. In other words, you should be able to figure out what X equals. So, the value of that variable, which would make this a true equation, is called the solution to the equation. Okay, so the solution to this equation is pretty simple. I think you probably figured out that I had $7 to start with, because 7 plus 1 equals 8, and 7 plus 1 equals 8 is a true equation. Okay? And when I say a true equation, 7 plus 1 truly does equal 8. Therefore, X has to be 7. It's the only value that could make sense for X. Okay? So, the thing about solutions is you just got to figure out what would you have to plug in for A to get a true equation. So 90 minus what makes 80? Well, obviously 90 minus 10 is what makes 80, so therefore A must equal 10. Oh, okay, that makes sense. Okay, how about this one? What would Z have to equal in order to make this a true equation? Well, what would you have to plug in? 5 times 11 is what makes 55, so therefore the Z must be 11. So Z equals 11 is the solution. Okay, one quick note on this. When you write your answer to a solution of an equation, don't just write the number 11. You need to write that Z equals 11. That's the solution. The solution is that Z equals 11. Okay? So, what if you had K divided by 4 equals 2? Well, what divided by 4 equals 2? 8 divided by 4 equals 2. That's a true equation. So the solution is not just 8, but the solution is K equals 8. I think you get the idea now. And there's a practice problem that I'd like you to try just to make sure. 17 equals X plus 1. Solve that equation. In other words, tell me what X must equal in order to make this equation true. Alright, the funny thing about equations is you can do whatever you want to do to an equation as long as you do the same thing to both sides. So that means you could triple both sides of an equation. That means you could double the left side of an equation as long as you double the right side of the equation too. It means that you could add 18 to the right side of an equation as long as you add 18 to the left side of the equation too. The key word here is balance. You need to balance out whatever operation you do to each side of an equation. That might be kind of a weird thing to suggest doing, but let me show you an example. You can do whatever you want to do to an equation as long as you do the same thing to both sides. So, is this a true equation? Does 6 plus 1 equal 7? Yeah, that's true. Watch what happens if I add 10 to both sides. I can add 10 to the left, and I get 6 plus 1 plus 10. As long as I add 10 to the right as well, 6 plus 1 plus 10 is 17, and 7 plus 10 is 17. I started with a true equation, and I ended with a true equation because I did the same thing to both sides. As long as you keep it balanced, you're good to go. What if I wanted to get real crazy and subtract 2 from both sides? Well, as long as I do the same thing to both sides, I still have a true equation. And you could keep on going and going and going, and you could do whatever you want to do to an equation as long as you balance it out by doing the same thing to both sides of the equation. Alright, now, what if you have x plus 5 equals 11? You might be able to figure out what x equals right off the bat, but I want to show you a little technique for solving equations. We're trying to figure out what x equals. So I'm going to subtract 5 from both sides. I'm allowed to do that because I'm going to do minus 5 on the left, and I'm going to balance out that with a minus 5 on the right. Why did I choose to subtract 5 from both sides? How come I didn't choose to multiply both sides by 83 or divide both sides by 100? Well, I chose to subtract 5 from both sides because my goal is to try to figure out what x equals. That's what I'm trying to do. I'm trying to solve this equation. Okay? And if I subtract 5 from the left, then I'm going to have 5 minus 5, and 5 minus 5 cancels out and helps me realize that all I now have on the left is an x all by itself, and when you do 11 minus 5 on the right, you get 6, and I just solved the equation, didn't I? I figured out the solution. The solution is that x equals 6. Okay? So, figuring out what x equals is what it means to solve an equation. To solve an equation means find out what x equals. And that's what we did. And subtracting both sides by 5 is the technique that we used to get to our solution. Okay? But remember, the value of the variable which makes the equation true is the solution. So x equals 6 is the solution to this equation. But solving an equation means to find out the value of the variable, and we did that, I think, but how do we really know that x actually equals 6? Well, when we plug 6 back into the original equation, what does it give us? It gives us 6 plus 5 equals 11, and you can check your solution by plugging it back in and seeing if it works. Is 6 plus 5 11? I'm pretty sure it is, and so we can circle that solution, we can put a big check mark, and we can move on with confidence knowing that we solved that equation successfully. We really did get the actual true solution. X really does equal 6. Alright, now I just want to practice this on a few more problems. And I want to show you what you can do to both sides. Well, what can you do to both sides of this equation? You can do anything you want to. But I'm going to tell you about what are called inverse operations. Just like on the previous problem, we subtracted 5 from both sides, I'm going to do what's called an inverse operation or an opposite operation here. Whoops, sorry about that. An inverse operation or an opposite operation. Okay? Notice I have a plus 6 right here. What's the opposite of plus 6? What's the inverse of plus 6? Minus 6. What's 6 minus 6? 0. So this is really a plus 0, which is just a. Do you see how doing the inverse operation is going to help me solve for what a is? Yeah, but I can't just subtract 6 from the left. I've got to keep this balanced. I subtracted 6 from the left side of the equation. Now I've got to subtract 6 from the right side of the equation to keep it balanced. 29 minus 6 is 23. And I think I've solved that equation. How do I know if I really solved that equation? Well, if I plug a 23 in right here, I would get 23 plus 6 equals, oh yeah, 23 plus 6 really does equal 29. So, check, A actually does equal 23. That's a valid solution for this equation. Let's practice that a few more times. Alright, if you've got b minus 10 equals 19, what am I going to do? I got to figure out what my inverse operation is. Well, this is b minus 10. So my inverse operation is going to be plus 10, right? Because minus 10 and plus 10 cancel each other out. But I'm going to draw a line here to show that I added 10 to the left, and I need to balance that out by adding 10 to the right. So what do I get on the right? I get 19 plus 10 is 29. What do I get on the left? I get negative 10, positive 10. They cancel each other out, and I just have a b left, right? And then I just drop my equal sign down, and I have my solution. But wait, before I declare for all eternity that I have solved this problem, I need to make sure that 29 actually is the correct solution. Would 29 minus 10 come out to, oh yeah, it does come out to 19. So, boom, I have successfully solved this equation, and we are ready to move on to the next problem. Couple more examples just to make sure that we know what we're doing. Inverse operation here. This time I have to look on the right side of the equation. I'm trying to get this z by itself. So I've got to get rid of the minus 8. What am I going to do to get rid of the minus 8? The inverse operation. The inverse of minus 8 is plus 8. So, what am I going to do? Well, I added 8 over here on the right side of the equation. I've got to add 8 over here to keep everything balanced. What's 6 plus 8? 14. Drop that equal sign right down. And now, I'm going to have this z, but the minus 8 got canceled out by the plus 8, and I'm just going to have my solution, which is 14 equals z, or z equals 14. So, 14 equals z is my solution, and I could check that by plugging a 14 right here. 14 minus 8 is 6. We're all set. Couple more practice problems just to make sure. Okay, y plus 16 equals 8. By now you should know what I'm going to do. You should know that I'm going to do the inverse of plus 16, which is minus 16. But, got to keep it balanced. So, I'm going to subtract 16 over, oh, that's interesting. Are you allowed to have negative? No, yeah, I guess so. 8 minus 16 is negative 8. 16 minus 16 is nothing. So I'm going to have y equals negative 8. I probably shouldn't circle that yet. I probably should plug that in and see if it works. Negative 8 is what y is supposed to equal. Is negative 8 plus positive? Yeah, I guess that comes out to positive 8, right? Because if you have minus 8, but then you go forward 16, yeah, okay, that works. That's the same problem we just did. How about this one? What's the opposite or inverse operation here? Adding 1 to both sides. Because negative 1 plus 1 is nothing, and you can tell me right now my solution is y equals 20, because 20 minus 1 does equal 19. Yes, it does. So, I've successfully solved this equation. Alright. What about when the variable is here? I'm not going to do the opposite of plus f, which is minus f, because the whole problem is I'm trying to figure out what f equals. I actually want to get rid of this 12, right? The 12 is what I want to get rid of. So how do I get rid of a 12? Well, the way to get rid of a 12 is to take away 12, because 12 minus 12 is nothing, right? 12 minus 12 is 0, and 0 plus f, well, that's kind of like just saying f, right? Okay, that makes sense. But that's not a solution, just the letter. Oh, okay, I forgot. I subtracted 12 from the left. I've got to subtract 12 from the right. What's 50 minus 12? Well, 50 minus 10 is 38. Okay, now I just have to go back and check and see. If I put a 38 here, is 12 plus 38 50? Yep, it sure is. We got ourselves a solution. I think by this time you get the main point. So, your practice problem is, I want you to go ahead and solve this equation using inverse operations or opposite operations, and I want you to show the steps that you're using. I want you to make the little lines. I want you to show what you're going to do to the left. I want you to show what you're going to do to the right. And when you give me a solution, I want you to write the solution as x equals something, whatever that comes out to. Okay, and then, of course, you're still not done, because what are you going to do when you get that solution? We're going to check our solution to make sure that it works before we move on. All right, that's all we got for solving addition and subtraction equations.